Blackout Comms is a secure off-grid texting and location sharing system that helps you securely send text messages, location, and more without using any grid services. Our newest prototype has a built-in thermal camera, and I'm going to show you how to build it yourself. As I said, Blackout Comms enables you to communicate with no grid. Blackout Comms uses LoRa frequencies, meshing, and decentralized packet caching to keep your private off-grid cluster connected. To build your own thermal communicator, node, proximity sensor, or any other device we support, visit chatters.io for full instructions. Download the DIY guide on our website and check the parts list. It's all things you can easily order online, mostly from Amazon. Now, let's build an encrypted communicator with thermal cam. First, you'll need to 3D print your case or find someone who can do it. You can download the printable files for free at our website. The build mostly involves making connectors for quick and grove adapters and plugging everything together and putting it all into the enclosure. I've sped up the assembly for you. It took me about 30 minutes. On the left side, I'm connecting the adapters by soldering a few wires together. There are other ways to do this where you wouldn't have to solder. On the right, I've finished connecting the wires and I'm putting everything into the case. Remember, do not try this if you're not confident working with electricity because mistakes can be dangerous. The real hard part is designing and building the firmware. But don't worry, we already did that for you. Add a compatible blank SD card and connect the communicator to our PC. Put the device into boot mode by holding the trackball button while powering on the device. Visit our firmware flash page in Chrome. On the flash page, you'll want to choose TDEC Custom and choose Continue. Our installer should take care of the rest. After the flash is finished, you can restart the device, and you should now have a thermal communicator. If you already have a private mesh cluster setup like I do, you'll want to onboard or invite this new device into your cluster. I've already done that here. Within a few minutes of onboarding, all your other devices will begin to notice there's a new thermal cam in the cluster, and they'll be able to interact with it. Now I can send encrypted texts, automatically share location, and end thermal images to other devices in my cluster. If the other device is within range, the message is usually sent instantly, received, and confirmed within seconds. If a device is not in range, your cluster works together to find a mesh path to become available that will get your message delivered. If you have a brand new device, like this one, it might take several minutes for message deliveries at first, until your cluster learns enough about your new device. This thermal image is broken into 9 separate data packets, asymmetrically encrypted, signed, and delivered in pieces across 9 different unpredictable frequencies. The entire image, as well as any text, is digitally signed using elliptic curve, so the TDEC that receives it can be 100% sure the image was authentic and unmodified. When the recipient TDEC receives the message and verifies it, it sends a digitally signed confirmation back to the thermal communicator, which shows as a check mark. It means you can be 100% sure the message was fully received. To build your own thermal communicator, node, proximity sensor, or any other device we support, visit our website for full instructions. Thanks for watching.